Hi everyone, welcome to tutorial 3, forecasting univariate processes 2 of ECON3350, applied econometrics for macroeconomics and finance. Today, first of all, it's the 8th of March, so this is the International Women's Day. So happy International Women's Day for all the women watching it live or watching this video later. So little virtual flowers for all of you. And for the men, make sure you say the same for the women around you. Okay. Next, let's continue with do some admin for the course. You might have noticed that the first quiz is available it's available now, and you have until March 24th. So not this Friday, not next Friday, the other one to solve it. So make sure you read all the instructions. I think the biggest thing that people have been asking and discussing a little bit is that you might have seen on the ECP that there is a 10 minutes restriction, but this is not what's going to happen. You can open and close it, save your answers, close, and come back the next day as many times as you need. Yeah, just wanted to call attention for that. Your quiz will be marked out of 5, and it contributes to 6% of your grades. Okay, there will be 5 of these quizzes. Other than that, I also would like to call the attention. We have for this course, I'm not sure if I've mentioned the recordings yet, but we are using Add Discussion Board. And it's a very nice way of doing it. It's not just the plain discussion board that we had before. For example, someone asked a question here, and it was possible to answer it using the slides. And then at the end, it was also possible to add a little bit of an R code, which it's possible to run and extract a PDF. So let me show you where it is. If you enter student view, you will see here add a discussion board. When you click there, for example, the question was this one, ACF, BACF, and this is how it works. If I run the R code that is there, it extracts a PDF. So it's a pretty interesting way of asking your questions if you want. And a lot of times the question you have might be the question that other students have too. So maybe before asking your question, you can come here and see if there are any questions inside of quizzes or assignment 1 and 2, tutorials, lectures in general. Okay. So I thought I should call the attention for this nice discussion board we have for this course. And now let's go for the tutorial, So today, at the end of this tutorial, we should be able to estimate a set of specified ARMA, not just one, but a group of ARMAs using 4 loops. We will use information criterion to reduce the set of models we have. Information criteria and residual analysis. And we will generate forecasts and predictive intervals for specified ARMA models and ARIMA models, and compare and evaluate forecasts obtained from different ARMA models, right? So, as a next step, I would like you guys to save the merc.csv in the folder you're planning to have this week's tutorial, all the files and everything. Probably you want to save the PDF too. To find that, just in case you don't know how to get there, go to Learning Resources, week 3, then tutorial 3, and then you can save these files. So if I do it myself, for example, I would look for 3350, click that, Learning Resources, week 3, then I go tutorial 3 and save the file, whatever I want. I have my own folder, tutor 3350, tutorial 03, and I save merc in there. Yes, I would like to replace it. If you open the CSV, you will see these observations that we have. Merck is it's a company. So what we have there are information about the shares from Merck, Merck shares. Let me go back to my folder. Where is it? 3. If you can, since it's a CSV, usually your Excel will be able to open it right away. Maybe it's associated with something else, but you will, just if you're curious. So you have date, you have the opening value, highest value of the day, lowest closing value, and then we're going to work with the adjusted close, okay, for this one. Now, something that might be new for you, if you haven't done ECON3350 with me, if I wasn't your tutor, or today, the code will be a little bit long and it's a little bit complicated, particularly from today on to the rest of the semester. It would be quite challenging to type all the 4s and make sure the code is correct by the end of the tutorial. So what we're going to do is to share the code with you, and then I will explain what's going on there. So if you go to codeshare.io, let me see if it's not opening. Okay, yeah, it opened. For people watching it live, I will post this link in the chat so you can save. So from here, CodeShare is a website where we can share some code. The issue with this website is that everybody is able to edit it. So if you come here and delete part of the code, the rest of the students won't have. So please make sure you just copy and paste in your own script. I can see some people are already using it. But if by any chance you get there and the code doesn't seem to be complete, let me know and I can post the same one for you. So I'll do it myself too. If I selected everything, copy it, I would come here to our studio. Let me close this one. I would create a new script. Then I would paste. I use Control V, or maybe Mac will be Command V. I would paste the whole code in there. Then I would save it in the same folder where I had the Merck file. You probably won't see the Merck file there because here it thinks it's looking for an R. I'll call it ECON3350 tut03 live. And that's it. Here we have the code. The rest of the things should work from here. Next. So let's look at the questions, right? The file merck.csv contains daily data of stock prices of Merck & Co. Incorporation. MRK is the code during 2001 until 2013. In what follows, we use YT to denote the adjusted closing prices, ADJ underline close in the data, as I showed you before, at time T. So this would be the contemporaneous that we're looking at. So A, load the data into R and construct a data set with observations in the range 1st of January 2011 until the 31st of January 2012. So we have data since 2001, but we're going to eliminate most of it. We're just holding 1 year and 1 month of data. So the whole 2011 plus January of 2012. Okay. Let's go there. And so let's go with the code. The beginning of it, you probably remember, it's a command we use a lot. It would clean the environment if we had something there. I usually start my code with it. Next step would be to install forecast. It's probably a package that you don't have installed, so I left it uncommented. Please run the install package forecast and then run library forecast to load this package. An interesting note about it, this package is maintained by Rob Hindman from Monash here in Australia. So pretty interesting that. It's a local thing. So I have already installed this this package, so I don't need to, if you want to check, it will be here. So when I run library forecast, you have a little tick in there and it is loaded. Now, I want to show you something else. You could, if you have already saved your file inside of the folder, you could come here, session, set work directory, and to source file location. But I like to share with students this line of code that does that for you. So instead of looking for the menu and for the folder and whatever, this line runs straight and set the working directory to the same one where you saved your script. The thing is, there is a chance you might not have the RStudio API. So please run the install package RStudio API first, and then let's run this guy here. Set work directory, and if both of this worked, the next line should load merc.csv the way it should be. Look at that. So if by any chance it doesn't work, you guys that are live now, please send me a message on chat and we can have a look what's going on. But at the moment, this is what you should be able to see after you've run all these parts. Okay. Next. The question asked us to filter just January 2011, 1st of January 2011 until the 31st of January 2012. So what we're going to do is to first create this selected sample, and this will contain the dates that we want to use. Dates that are, you will see my data date from the that are greater or equal to 2011, month 01, day 01. It's in the American format, and my data date is smaller, less than or equal to 2012 01 31. So this is just a comparison happening, and when you run this code, you will see false, 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 and probably it will be false all the way from 2001 until 2000, the end of 2010, and the beginning first of 2011, then it becomes to be true. These are just dummy variables as we've used in ECON3350, Introductory Econometrics. So the falses, you can also take them as zeros, and the trues, you can take it as one. So it's being shown as false and true here. So if I double click, I just selected the variable name and run, you will see these loads of things, but unfortunately it stopped at 1000 prints, omitted the rest of it. So there would be some truths later on, okay? Now, extract the values only for the selected sample. Now we have this variable y, it's our yt from before, and we are getting S matrix, and this is just to make sure this data is coming in a matrix format. And we're using, you're getting my data adjusted close, and just for the period of time that we selected. So, you know, adjusted close, it's here, and we have 3,268 observations. But when you run this one, notice that Y will have only 272 observations. And just in case you're curious, you see the first value is 27.5. So we can go there and check amongst our 3,200 lines. Let me scroll down, way down to the bottom. 2011, I would like. Oh, a little bit lower. This is one way to check if you're capturing whatever you want. Hey, wait, did I pass 2011? Sorry. I did, sorry. Okay, beginning of 2011. Adjusted close. 27.5. It looks all right for this and this. It got both. It got 1 day less, but I think this will be adjusted later. Let me see. Yes. All right. So we get 1 day before, because when we do the diff, it has to use the difference between the previous one and the current one. So, okay, why? As you can see, we have a much smaller sample, 272 items, comparing to the whole sample, which was 3,200 rows observations. Okay, now let's go. This is what we did. Now it's asking us to construct 2 other variables using y. First, it would be change in prices. So delta YT, which is equals to YT minus 1. So for example, changing prices. If we're considering both these first prices here, I said it captured the first one. Now that I saw the 0.7, it didn't capture the first one, captured 1st of January. So when we look that, the delta Y would be 27.7 minus 27.5, which is YT, the second one, minus the first one, YT minus 1. When we calculate, and it's very easy to do it in R, it's just the function diff. So when I press enter, you wouldn't be surprised that the first value is 0.236, which seems to be the difference between these first two. Thing to note when you're calculating a difference is that you lose one observation, as I kind of mentioned before. Usually the first observation you have, there's nothing behind to compare to. So sometimes you might have to treat that. So adding one more item to compare, but it's not necessary in our case here. Second, it's a very common thing used in macroeconometrics. It's called the log difference. Look how it looks like. It is the, we will call it RT, and it will be the log of YT divided by YT minus 1. Also, if you separate the log, would be the log of YT minus the log of YT minus 1. It works both ways. And usually this, for example, the first one would get you a difference like from 1 day to another in dollars. So it went up $3 or went out $4. But the log, it's a difference on itself. So it would say it went up by 1%, went down by 2%. If you remember for ECON3350, it's something that we use a lot. If the change is relatively small, it means a little bit like the percentage change. Okay, so let's go. We created dy. Let's create R. So we have R there, dy, 271 observations each, just one less than 272 from Y. All right. Next thing, we give names to the columns. So pretty much the name to the columns we're giving is just the a value to, for example, if I click dy now, it says V1. We're just putting a name in here. So let me run these 3 guys. Now, if I click dy, change in stock prices. So it's our delta Y. The little y will be stock price of Merck, just our data. This is the concept that we a name that we use. The data, the values, the way you get it, we call it level. So they are, when you do the difference, then it's the difference, data in differences. But the first one, we call it levels. It's just a name that it receives. So it's the actual level that it is measured. And finally, log returns. So the increase or decrease in percentage. Yeah, which should be here, log returns. All right. That was question B. So this is what we did. Next, D. Draw time series plots of YT, delta YT, and RT, and comment on the stationarity of the processes that might have generated these observations. So, one important thing, the data is not stationary. We don't talk about the stationarity of the data. We talk about the stationarity of the process that might have generated these observations. Okay, just something to point out. So first, we will use only the data of 2011. So let's go. I'll run this one. This one is select just the dates from that are as date. Well, we're sorry. First, we're creating this cell 2011. Then we're getting all the dates from our selected sample. So 1 year and 1 month is here. I will run this one too. But now I'm plotting the dates, but only for 2011. So let's go there. First one. This is for YT. So look how it goes. It goes up and down, has some let's say variance, some volatility happening. And sometimes there's more volatility, sometimes it's a little bit more stable. It's a bit hard to judge the way that we're getting used to judge things. So this data doesn't look like a stationary data. Stationary data usually will run around 0 or will be just oscillating around a value, but usually 0. Look when we take the differences. So pretty much how much it changes from one value to the other. Look how much it changes. Now it looks like something that is just, if I move, you guys won't see. It's just oscillating on the same thing. Looks like the average is 0. So this, although the variance, it varies a lot here, doesn't vary as much in other places, like small variance here, much higher variance. We still would say this looks a lot more stationary than the previous one. And if I plot the log return, as you can see, it's not a lot different. Log returns in diff tends to give you very relatively same information. It's not the same. The difference in log is that it's compared to itself. So as you can see here, the 0.02 for the log would be 2% and minus 0.06 would be minus 6%, right? If I go back and look at dollar differences, we have here 50 cents and minus 1.15, which would be minus $1.50 difference. So this depends on the price of the stock at that point. So one thing would, if the stock price was $100 here and then it becomes $50 here, these things are not really compatible anymore. You can't compare because it's going up. You can compare in terms of dollars, but like it's not really a bump in one place is different than a bump in the other. While the log returns, the log difference, you can compare. So it's going up 1%, it's going down, I don't know, 3% based on the current price. All right. And that's what usually what matters when you have your portfolio. You want to look how much your portfolio is changing in percentage, not the actual value of the stocks. So that's it. The plot difference and log returns look a lot more stationary than look at the data in levels. Okay. As you can see, you will also get from the code a little bit of an answer there. For people that are live, feel free to jump in and ask a question if you feel, or post something on chat. I'm happy to answer if there's any other question. Okay. All right. So that's what we were comparing. Now, let's compute the plot and compute and plot the ACFs and PACFs and see the difference between when you look at the data in levels and when you look at the data in difference. This is basically the code that we just used, right? Let's go. First, let's look at the data in levels. As you know, this is how it looked like before, not super stationary. And we run ACF. And then if you look at the ACF, let's start with it without looking at the PACF. It looks like a geometric decay. So we start thinking, oh, maybe an autoregressive process. And it is very close to 1, as you can see. Like this lag 0 is always like 1 equals to 1. And then the next one, it seems above 0.9, kind of 0.95 or more. Then it's like if we had an A1 pretty high, like 0.9596, then let's look at the PACF. We don't see very clear signs of the oscillating decay that we have from MA. And we also only see 1 lag for the MA. So based on the analysis we did before, let me click here once. Ooh, where is the answer? Oh, the answer is already here, sorry. Based on the analysis we did before, this will give us a conclusion that looks like an AR1 model. But a little bit of a caveat to this analysis we did. To run the ACF and PACF, we assume the data is I can't say that. We assume the process that generates data is stationary. So this is a problem when we look at it and it doesn't look like stationary. We're making an assumption that doesn't really hold for the plot that we had. All right. So this is what we thought. If we run ACF and PACF, it's an AR1. That's what it looks like. Now, running the ACF and PACF in here for the differences, look what we get. Now, the first lag, lag 0 is 1, as we always have, but nothing else is statistically significant. Or maybe if you want to point out that like there is one little guy here at like 10 that is relatively significant. But other than that, none is really significant. Then we go to the PACF. And it's not really significant. But in a certain way, it seems like it's oscillating. There's kind of an oscillate decay. Once again, the lag 10 indicates there's something going on there. But in this case, it is not super clear, but it tends to be going towards MA process of 1 lag. And this oscillatory decay is what is indicating that. So in terms of analyzing using ACF and PACF, that's the conclusions that we get from what we see, right? Let's go to the next one. Now, propose and estimate 25 ARMA models, ARMA PQ models for delta, for the difference only. Now we're not looking at levels anymore, for delta YT. How are we going to do that? When they say 25 ARMA models, they are asking us actually to run from 0 to 4 on P and from 0 to 4 on Q and do all the combinations we have for them. So to do that, we will start by creating a matrix that will save the information from each of our models. And it will be the information criteria, the AIC that we were looking last week, plus the BIC that we learned this week during the lecture, the Bayesian information criteria, Bayesian. And look what we're creating. First the matrix, but now let's just also add names to the columns of the IC, and I want to click. Right now, it's an empty matrix, but you will see here we will store how many legs we have as an autoregressive model, how many legs we're using as a moving average model, Q. And then what was the information criteria? How much was the score, if you want to call it, in the ICAIC and the Bayesian one? Okay. This is what we created first. It's a place to store the information criteria. Now, we are going to run all the ARIMA processes. And to do so, this combination from 0 to 4 for P and from 0 to 4 from Q, we're going to do a for loop inside of the other one. As you can see, there is one inside of this other one. The first line will run this ARIMA process, and this guy here, starting with a capital ARIMA, it's not exactly the same ARIMA we used before. This one, if you go to help, you can look for capital ARIMA. It's coming from the package forecast that we used before, the one we loaded here in the beginning. Just by using capital R is case sensitive, so it already understands that this is the one we're talking about, the forecast one, not the one coming from the stats package, okay? And then we're going to say, let's analyze this data that we have. We're calling difference I, dy. And the order, as we did last week, will be just receiving a concatenate of P. Then 0, as you remember, this is what we do for AR. 0 is the difference. And now it's interesting because we've been talking about difference, right? We're attributing a 0 here. And then Q, it's the amount of legs for MA. So first we run all these guys for 0P. It starts with 0, then goes here. First one, 0 here. So 0, 0, 0, which is not really relevant for us. But then it goes 1, 2, 3, and 4. Then it starts all over again. 1 here. Then 0, 1, 2, 3, and 4. And there it goes. So a lot of explanation for 4 inside of the other, a nested 4. So Control Enter. And it just ran everything we needed. Now you will realize if you click IC, now we have a few things there. And look, P, it starts with 0, 0, and these are the points that we had. Then 0, 1, 0, 2, 0, 3, until the 4, 4. In the end, total 25 runs, 25 models. Now, if you remember, well, AIC and BIC, it's kind of a penalty that we apply for using a lot of legs and for having a high R squared. Eric was talking about it in today's lecture. So if you want now by hand, you can sort it out and see the best models based on the AIC. You see 1, 2 is the ARMA 1, 2 is the best model in terms of AIC, then 2, 1, then 1, 1, 4, 3, 4, 4. But if you sort it by BIC, a lot of things change. And this is really interesting. You will see throughout the course that BIC has a slightly larger penalty for extra legs. So the AIC will be more, will accept a lot of legs better than the BIC. BIC will usually favor smaller amounts of legs. Okay, what we're going to do from here, so we generated 25 ARMA. This is the code. Now use the AIC and BIC to reduce the set of ARMA BQ models. So I think let me go back just a little bit to explain what was going on. I think I skipped a little bit of the process. I ran the force. There are two things happening inside of the force. One that I said, it runs an ARIMA and it stores it inside of this fit PQ. Second, it will get the IC from here and calculate. Let's get for each of them. It will say, okay, line, let's input in that. First, this is a calculation of the line. So will be P times 5 plus Q plus 1. It's a little bit of a calculation to understand how it positions each of the results. So we can have this guy there in the end, okay? The information going in is the p-value, the q-value, and then the fit pq with the AIC score and the fit pq with the BIC score, and it ends up looking like that. I think just thought I should point out where it happens. Okay. Now for F, you will see, as I showed you, by clicking an IC, you can print IC. You will see the same table, the same matrix. And by it says a quick look through, you will see that the scores don't agree too much with each other. So we're going to filter the top 10 for AIC. And if I click that, these are the top 10. Now we're going to get the top 10 for BIC. It's here. And if you print them, you will notice that they don't agree with each other too much. So let me use the slides where I have all of them at the same time. In order, the order that they were printed, it looks like this one. So this is just organized by P and Q first. Then the top AIC are these guys, and the top BIC are these ones. There is no right way of selecting the models. Should we favor BIC? Or should you favor AIC? It's not a clear thing. And there are many ways to approach that. Right now, what we are going to do is to select the models that are part of the top 10 in both lists. So the models that are top 10 in AIC and BIC are the ARMA 12, 21, 11, and 30. You'll see here. And for the other ones, you will see there's no overlap. And after selecting these 4 guys, we're just manually added to a list that we will call adequate set. So it's the set of adequate models. In this situation here, we were adding it manually, but if you want, you could use a little bit of extra filtering and code to select it automatically. But there's no one right way of doing it. So sometimes you just need to have a look and come out with the best strategy to select your criteria, your models. So I'll run this one. And now we have an adequate set. It's a list of 4 guys. And you see length, and it's already saying what it is. The I is 0, but the P and the Q is here. Open and close. Okay, I'll close this guy. I think that's it for question F. And maybe you'll feel like we're going a little bit quick in the beginning, but the beginning, it's pretty simple coding. And the last questions where we're running the forecasts is where things are a little bit more complicated. So that's where I'm planning to spend more time on. Okay. All right. No questions yet. So G. Oh, sorry. Draw time series plots of the estimated residuals to obtain for the ARMA model selected in the previous question. For the ARMA obtained before. Comment your findings. Run the Young box test at the alpha 5% significance level to test the white noise hypothesis on estimated residuals obtained from H ARMA in the set obtained from part F, and report the test results. So we're going to use a very useful function from the forecast package called check residuals. And it will print us all these interesting plots and also run a Young box test for us. So I will move to Studio so we can do that. You will see it's a super simple for here, just going from 1 to the length of adequate set. So you guys know our adequate set. If I run just this tiny bit, will be the 4 models. It means the length should be 4. So for I from 1 to 4, let's check the residuals of dy select like we're running the ARIMA again here because it doesn't take too long. We're just running the ARIMA again for each of the adequate sets. So will be the first row, second row, third row, and fourth row from the adequate set. Okay. This, depending on the computer, it can take a tiny bit of time, and it automatically plots the results in here. So let's have a look. For our first model, let's go there, 101, you will see the residuals. And if you don't remember, residuals, when you do a regression, it's what is left out. So it would be, you have a regression line, the residuals is the distance between the line and your actual value, right? If it was a linear regression. So for the ARMA models, it's how much the stochastic model you're trying to apply, how much it misses each of the points. That's what we're looking at. These are the residuals. And there doesn't seem to be any real pattern here. So it looks like what we call a white noise. So the average seems to be 0 or close to 0. It's oscillating around 0. And it seems to have a constant variance. We're not worrying too much right now, but apparently the variance is not something that's screaming, we are different. You can look if the mean is close to 0 here. The highest level seems to be on 0. And also, if we run an ACF on those residuals, that's what we get in our ACF plot. Look how interesting. So there is no autocorrelation of the residuals. So this looks like, by looking at the plot, it looks like it's a white noise. The most useful thing we do, it's not the visual, let me say it again. The most useful output from this function is not the visual one we have, which is also really useful, but in our course, we will pay a lot of attention to the p-value. This Young box test is testing a null hypothesis that the residuals are white noise, so mean independent and homoscedastic, so constant variance, and mean independent, so probably mean equals to 0, expected value equals to 0, right? Look at what we get. Do we reject the null hypothesis of white noise? We don't, because we're looking at a 5% as the question asked, and we have way more, a p-value much more than 5%. We have a 0.43 of p-value. So we don't reject, and it's a good thing. This is how we interpret the first one, and you will see it. The second one will be 0.49, third model will be 0.48, and the last model will be 0.12. It's getting a little bit closer to 5%, but we still don't reject. So we consider all the 4 are okay, and we have white noise for all 4 models. So let's have a look here at the visual. Not a lot of difference. You'll see still mean independent and relatively constant variance. ACF, nothing screaming wrong on the ACF, and it seems like the mean is 0 here. Next one, same thing. Seems like the mean is 0, nothing there, and a little bit more variance apparently. No, same thing. And finally, the AR3 model shows a tiny difference. You just feel because you're comparing one after the other. And on leg number 10, we have a little bit of autocorrelation on the residuals. So probably this is what made the L-Young test come a lot closer to 0.05, but not close enough for us to reject the null hypothesis of white residuals, white noise of our residuals. Okay. This is it for this will be important for your assignments too, this interpretation. Okay, and we have an answer. I put all the values here together. Then H, forecast changes in the MRK stock prices. in January 2012. So let's use the data from 2011 and try to forecast the next month. For each ARMA model in the adequate set, compare your predicted price changes with real price changes in the data. So we're not only creating our point forecast and the forecast bands, kind of confidence intervals for our forecast, but we're also plotting the real data on top of it. So we can see if our forecast it's good or not, was good or not. Okay, compare the forecasts you obtain as well as their quality across ARMA models and comment on the robustness of the generated forecasts. Lots of fun now. This is the meat part of our tutorial. So we need to, oh, I wrote it wrong here, forecast this, missing an E. We need to set a few things before we start running the forecast. First, what is the horizon of our forecast? How many days are we forecasting in the future? And to do so, we're going to say the sum of selected sample. So pretty much we're summing the ones that we calculated before, the amount of days we had for the whole sample. And we're subtracting the sum for 2011 from it. So we used to have, where is it? Cell sample. Cell sample will be very long. The amount of truths or the amount of ones we had that, I don't know, a year and a month, probably almost 400 observations. Now we're taking 365 from 2011 and we're left with 20 observations. It's actually, I said 365, but it's not. We're looking at the days where the stock market was open. So it's probably a lot less. 5 times 52, 250, 260, I think will be a more precise amount. There are some holidays in between. But yeah, then we're left with just 20. When I run that, you will see horizon, it's equals to 20, right? X-ticks. This is just a little guy who will point something for us where we want to add some dates, interesting dates. This guy will point towards the start of our plot. It will point towards the end of the observed data, which will be 2 times horizon, which is 40 days of open stock market. And finally, we'll point to the end of our prediction, which would be 3 times horizon, so the next 20 days. We're not printing the whole year, we're just printing the last 40 days observed and our 20 days prediction, okay? This is what this X-ticks is pointing at. It's not even saying the days, it's just getting the position there. Okay. Now, actual difference dy. This is where we're going to save the actual values that we found for January 2012. So look at here, it's actual dy receives as matrix, and then we're looking inside of our difference matrix and selecting everything that is not 2011, right? We had 2011 in a month, now we're selecting just that month that is in 2012. Extracts the actual values for January 2012. Finally, we will create a list of forecasts, one for each model. So we're saying it's going to be a vector, so it will be 1, 2, 3, 4, and in the terms of list, and the length, it's going to be 4. So I'll just run it here once again, shows 4. And I think I haven't run all the things here, so I'll just run all the same time. This works too. Horizon receives 4. X-ticks, as you can see, are 3 positions in our data set. We're extracting the data later from those positions. Then actual dy will be pretty short. Where is actual dy? It's up in here. It's just 20 observations. If you click, these are the values for January. So actually, it's not even, it's missing 1, the 20th. And finally, forecast dy. Right now it's empty, but it's the list of our models. And our 4 will run from for I in 1 until 4. we will run the forecasting. And for each run, each plot we have, there are a few details we want. First, model PQ will receive our adequate set. So the first in our adequate set is going to be ARIMA 101 or an AMA 11. Maybe I think will be more visual if I run it first, and then I can point towards things that we're looking at. Look at the predictions there. So let's go back to the first one we generated, AMA 11, as I said, right? First, generate the forecasted values. Sorry if you want to fix this little typos, I have that. Forecasted values for the horizon HRZ and the bands 68 and 95. So to forecast, we're using the forecast function from our forecast package. Then we're generating the ARIMA again for the differences of Y. In 2011, the order, we're using the order we added here. So for the first run will be 101. Then horizon would be the 20 days. So I want you to forecast the next 20 days. And then the level are the bands that we created. And look at this bands. In light blue or kind of going towards purple, you will have the 68% confidence interval, not necessarily, but the band that for 68%. And in this light shade of gray will be the 95% shade, okay? Horizon, you see there are 20 business days in between the 30th of December and the 31st of January. That's our ticks. And what else do I need to explain? And it's a 01. So here we're printing as an AMA PQ, but I could also have said it's an ARIMA 101. Next thing, the next line is just creating a title so that this little guy here, it's written in a nice way. So paste is going to put a few things, let's say strings of characters. This is a little bit more coding language, but we'll put numbers and characters and things together into a same string. I don't know if I can call it that in A, but a same amount of text, as if you wrote everything with away in between quotation marks. So AMA, then the next thing, we will extract the model. Then next thing, we will actually we will extract just the first value of the model. So this part here writes this ARMA open bracket. This second part, we're just getting the first value, so it's writing this one. Then we add a comma and a space, the comma and space. Then we get the value for Q, the second one. So in there will be the third, because we put the order as an ARIMA model, so it will be 101. And finally, we also add the closing bracket, and we tell the paste function that we don't want anything in between the things that we specified. Sometimes you might want a space or a comma, and this time we don't want anything. So all of this is to automatically generate the title here, 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 and here. Okay, that's what it's doing. Finally, we ask to plot our forecast, the one that we just generated. We asked to include the horizon horizon times 2. This plot, because it's coming from a list of forecasts, it's already aimed towards forecast. So you have this include thing that we attribute. So you're telling, I want from the last day, from the day that we start forecasting, I want you to also look for 2 horizons before. That's what we're doing. Then YLab is pretty much the name that we have added for DY here. So changes in stock price. That's what you see here. And the title is the title that we just created in title PQ here. And finally, we're telling that the X labels should be empty to start with, because we're going to use the X ticks and the dates to create this nice thing here, the starting and end of our plot, and finally the end of our forecasting. Okay, this is what this line is doing. Next line, adds the actual values to the forecast. This is the line. So the forecast there generated this little blue line, the dark blue band, and the light gray band. This is the one that generated, added the actual values, the black one, which is the actual realization, oops, of the data that we have, right? So we're just calling it lines, and whoop, that's not change anything, and doing it one horizon from this thing they call one until horizon, it's another 20 days, and actual DY is where the data is coming from. Finally, we're almost at the end of this for. Finally, we are drawing these little 3 ticks that we created before. So in the axis, I would like to start in the beginning of the plot 1 at X ticks. So this is saying these are the values, X ticks, that we had. So 213, 252, 272. So when you look at this, it will look at the whole data that we have. Well, in fact, we are looking at these dates. Look for these 3 guys, 3 positions. So it's a little bit difficult to explain here, but it's looking at the data we have behind, looking for those positions. And then I'm adding the labels, the dates that you find for in these positions that we have here. So in that position, we have 2011, 1103. It's probably 2 horizons before, so 40 days, 40 business days before, which is almost 2 months. Then the other one is the end of the year, December. It seems like you missed 1 dot there. It could be the 31st, but still okay for us. It's a holiday. That's the 30. And finally, the end of January, the 31st of January, which is in here. This is what this one is doing, just drawing these little guys. Okay. Whew. So these were the 4 forecasts that we had. Now let's look at how they look like. For the ARMA 1.1, comparing it to the actual realizations, it seems like it's a pretty good forecast. And I want to call your attention that it has a little bit of varying, but it's pretty much straight. And you might be thinking about, oh, but Eric just told me that the further in the future we forecast, the greater the uncertainty we have. So it's supposed to be growing instead of being flat. And there is a little trick here. We're not looking at data in levels. We're looking at data in differences. So whatever happened in the previous period in terms of difference, this plot is showing how much it's going to change, whatever happened before. That's why the changes are kind of stable instead of growing. And in the future, we'll be looking at some of them who grows when we look at the data in levels, okay? So this is why it's flat. And the ARMA 1.1 model captures pretty well inside of a 68% level of confidence, kind of, the 68% band. It just misses in the end. Let's look at the next one, ARMA 1.2. It captures almost everything. It misses also in around the same place. Not a lot of difference. Tiny bit differences on the oscillation. ARMA 2.1 also same oscillation, capture almost everything, just missing at the same point. And finally, ARMA 3.3, a little bit more straight, not so much oscillation anymore, and missing the point the 68% band in the same points, but the 95 is still capturing really well. So running the forecast using the data and differences was really good. Apparently, we were able to fit in our main models, our best models. We were able to fit what ended up happening in real life, which is a very big win for us, right? What else? I don't think I missed anything. The thing about now trying to these are the differences. The thing, if you try to use those forecasts and move it the way it is to the actual values, then you need to be adding the differences one by one. And that's when your flat things will become a little bit growing on uncertainty. We don't do it by hand. We are going to use a better way of doing that. Well, so let's continue on the question. So this is what we did, our long for. It's not long, but I try to make sure we covered everything. And then these are our forecasts. They're very similar to each other and ended up giving us about the same result. Now, let me see. I think that's all. Last question. Compare the forecast you obtain as well as their quality and comment the robustness of the generated forecast. That's it. Yeah, 68. Almost everything inside of 68. Now, forecast mix price, YT, in levels this time. Instead of changes, instead of the delta, or the change, GIF, will be levels using the ARMA 2.1. So now we're going to use just one model of ARMA, just the 2.1. Compare your predicted prices with real prices in the data, as we did before, and compare the price for the price forecasts obtained in this part with the price forecasts obtained transforming the forecasts in part H. This will be the second step for this question. Hint: you will need to convert predicted price changes to predicted prices. Okay, from changes to actual prices. Predicted, not actual. Ooh. So let's go to R. Quite a little bit of explanation of the things we were doing. So for I, now instead of getting the actual of the dy that we had before, we will get the actual of y, actual values for January that we'll be using later to print it over here, right? So generated the forecasted values for the horizon and band 68 and 95. This time we don't need a for because they specified already. The question specifies which model they want us to use. It's an ARMA 2.1, so we can just go without the for. Just forecast y in levels receives forecast, our ARIMA with only selecting only 2011, order 201, ARMA 2.1, horizon, the horizon of 20, and levels 68 and 95, as we did before. Control Enter. Then plot the current data and the forecast line and bands. Now it's nice because you will see the plot being constructed. You will see that the title is already there because we don't need to be varying the title. We're just plotting one thing. But look at the plot. Look how it looks like. Now, it's not the differences anymore. Now we're looking actually at how the stock was changing in price. This is our forecast without the actual data. 68 bands, 95 bands. Now we add the line. Look what was the actual data. Now our forecast wasn't really good. Using this ARMA 2.1 for the data in levels. Yes, in levels. And now finally, we're doing the little axis in the bottom that I said before. Boom, there we go. Sitting there, indicating where things are. Now, you will notice that although when we are trying to forecast for data in differences, our forecast was pretty good. So what's going on with when we try to deal with our data in levels. Because look, it's still capturing the 95%, but it's pretty close to the upper bound. In theory, our forecast is that prices of Merck's share price is going to fall. That's what we're forecasting here with some uncertainty. And it doesn't seem it fell. It kind of kept its value or increased a little bit. One of the things we saw before is, and we talked about it, when we print the data, we are making some stationarity assumptions. And look at the difference, how it looks more like a stationary data than the levels one. Levels go up and goes down for a while, then goes up again, then goes down. That is probably one of the problems that is happening. Like, we can't make the assumption of stationarity when we look at a plot like that. Okay, so this is what is going on, and probably, or a possible cause of our mistaken forecast, or like not as good forecast. What else? Now, what they want, this is the second part. They are asking us to go through, compare your predicted prices with real prices. This is what we just did. Compare the prices forecasts obtained in this part with prices forecasts obtained by transforming the forecasts in part H. Let's make that transformation. So first, we made predictions about how much each day would change, but we didn't accumulate one with the other. Like, this is what's going to be in the end. It's just the changes, okay? Forecasting the changes, it looks quite flat. Forecast in levels, the confidence bands keeps increasing because the uncertainty increases, right? So how do we replicate the differences we did before? Now we are going to use a RIMA and the I in the middle. It's exactly the difference as we've probably mentioned before. Now we're making use of it. Instead of manually adding all the values, we will ask the RIMA function to do that for us. So look how it's going to work. First, we're dealing with the data in levels, okay? So we're calling Y0. It's receiving the adjusted close of, let me see, sum of data. So when let's run this one here. And Y0, it's getting the values. Where is it? Just one value. So, sorry. We're taking one value out of this data. Then, YEXT, if I run as matrix, look at what it's going to get. It's putting all the data from 2011 and also getting this adding this one little value there, the 27.43 to the beginning. So it's concatenating both 2011 and this first observation in here. Okay. Then we're going to create the list of forecasts as we did before for the 4 that we have. Same forecast Y, this is level, so forecast Y, list of 4. If you click, you'll see the same thing we saw before. Now, same 4 that we did before, relatively similar, so I didn't really add a lot of comments in it or to it because it runs the same way that is the previous one runs. And I think I will just run, and then with the pictures, I will explain what's going on. Okay, so Control Enter for this large 4, and you can already get a little bit of a spoiler what's going on there. Look, now we started the 4, I is 1. Let's get the first model in our adequate set. But to the second part of model, like the second value for ARIMA, P, D, Q, so the value in the middle, we're adding a 1 So we're doing a one of difference, which is what we did manually before. But now we get the data in levels. Just tell Arima, oh, I want you to work with differences instead of the data in levels. And that's what we're doing here. So now when I say model PQ, it will be saying, for example, 1, 1, 1 for our first one. And for our for the second one would be 1, 1, 2. So this is the one in the middle. Okay. The third one, probably the last one we run was the third one. So if I print just this guy, will be a 310. I hope I'm right. There we go, 310, which was the last one that we ran here. Now, what I'm going to do, actually, as we say in Arima, I will fix this code. I do want to see the I, and it will be there. Because I want this Arima to have a third value in the middle. I will share this. I'll double check. I think usually I extract these answers from Eric's answer. I'll check if I don't think he has. So maybe I'll do this suggestion. For people online and for people watching it later, I will copy this whole code with this now a little bit better looking Arima. Since we're talking about Arima, there will be 3 values. And I'll put on code share once again. I'll replace the code I have there. So if you guys want to replace what you just did, copy and paste the whole thing, feel free. All right. Now we have Arima's printing in the right way with a P, with a Q, and with a D, and with a Q. All right. So that's what we're doing. First, we run the Arima and create the forecast as we did before. Second, we create this little title, and now we have all items 1, 2, and 3. I could also, instead of doing all like this, I could just add a 1 here, but that's right. Because all of them inside of these loops will be 1 difference. But this is nice. Maybe you can use this code later on. Then, after adding the title, we create the plot, and we ask to look at 2 horizons back, like 2 horizons of observed data. Then give us the forecast. We don't need to tell. This plot is smart enough to give us the forecast. Oh, actually, we told it here. Sorry, yeah. We're telling the forecast is here. Then we ask it to include the observed values for 2 times horizon. Then we add call names as stock price of Merck. So first was the price changes in stock price we had. Now we're actually looking at the Y. We're looking for stock prices of Merck, MRK. Okay, that's where things are coming from. And the main, we're using the same thing here. And finally, we're erasing the x-axis labels so we can add this little things we have there. Then we have lines adding the actual values. So 1 plus tra-la-la-la-la. This is the length plus another one. And then until horizon and actual. So it will add, I'm sorry, I'm still talking about lines. So that it's adding this little black line here on top of the horizon. Fine, sorry. And then axis, we have a starter 1 as it did before, and then the ticks, and finally the dates. No, you will notice a little bit difference with the ticks here. Remember that when we take the differences, we lose one of our data points. So usually the first one you have nothing before it to get a difference from. So you will see that now we're adding a 1 here. Maybe this would be something to pay attention when you're coding your own project. Let me double check the previous one. We didn't have a 1 plus, right? Now we had to add this 1 plus. And this is what we get. We get the 4 plots for our 4 models. Let's analyze them now. First, when we went, that's not nice. I will empty my things because I want to go back and forward with it. So I will run the whole I again. Okay. I just run the whole thing, so we have all the plots we want. But particularly, let's look at the first one that we did without using ARIMA with a difference of 1 in the I, D equals 1. So first we ran an ARMA to 1 using the data in level. And as you remember, it was pointing to a fall in price, our prediction, and the actual values were not really well covered there. Now that we considering the difference, the prediction is much better, possibly because the assumption of stationarity works much better with the data in differences than in levels. And as you can see, our prediction is not for the price falling anymore. It's kind of staying still. It's not perfect, but we're still getting with what ended up happening in real life inside of our 68% band for the ARIMA 111. For ARIMA 112, we get the same, a little bit out in the beginning. As I mentioned before, now we estimated things in difference, but what you're looking, it's a plot in levels. These are the prices: $26, $28, $30, and $32. And also, that's why when you look at the confidence interval, the further the forecast goes, the more it increases. If it was difference, there's a chance it would be flat. Now you see it growing. Same thing for then ARIMA 112, another one, ARIMA 211, same thing, captures the same, fails a little bit in the beginning. And finally, ARIMA 310 fails a little bit less in the beginning. Seems a tiny bit better than the other ones, I would say. Pretty much the same, not a lot of difference. But that's the quality. So these 4 we just generated using an ARIMA model, indicating there is one, we want to work with one difference instead of level. It's much better. It's much more robust than the ones that we did without indicating a 1 there in the D, in the difference. All right. So that's the difference. That's how it works. We are not going deep in the equations right now to say why this one is better. You will see we're talking about it here, but you can see how much better it is based on the graph. All right. Well, this is what we were going to do for today before our optional question. So you will see ARIMA here, whatever the forecasts we found. Quite a long explanation here. Now we have time, and this is the recording, so we want the recording to be as complete as possible. So we're going to do the optional. If by any chance people that are online, if you have to leave, you can watch it later. This recording will come out on Fridays as usual. But now it's a little bit repetitive, but it will be, instead of using the difference or the data in levels, we're using the log differences that we calculated before. All right. It's important to think. So let's go, Jay. Let's think of it. I want to tell you, as I showed in the first plots, the way it behaves is not too different from the differences we got, right? For this data, that's how it works. There is a chance that some data might be a little bit different, especially if it oscillates a lot during your plot, the actual value, but we end up getting about the same results as we got from differences. So first, ACF, autocorrelation function. Boom. About the same. So remember, for differences, we found lag 0 is 1, like it is for all of them, but nothing statistically significant anymore in there. Just a little bit of potential for day 5, a little bit of potential for lag 5 and lag 10. And I would like to remember you what is going on here. I don't think I didn't mention before, because the 10 was calling more the attention than the 5. But if you think this is daily data and the stock market is open every 5 days per week, So what might be going on here? So if I'm looking at Monday data at our lag 0, what is this one? It's Monday last week. And this one, it's Monday the week before. And this one would be Monday the previous week. And this one would be Monday 4 weeks ago, which is also pretty close. So maybe it's not really a coincidence that these guys have a little bit more correlation than the rest of them. Maybe there are things that happen in a specific point of the week. For example, Monday, it's coming after a weekend of, let's say, suppose changes in news happening, things happening. So maybe Monday tends to be have a little bit more variance from Friday to Monday. I don't know. Could be the case. So not too surprising here. All right. ACF, we don't take anything. Probably looks like an MA in this case because it falls to 0 right after leg 0. PACF, not a lot of things statistically significant, but it's still oscillating. Negative, positive, negative, positive, negative, positive, negative, 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 positive, positive, a little bit like that. So maybe a suspicion of an MA there. Given we have no legs on the ACF, maybe an MA1, but this type of interpretation are not really super relevant for us anymore because we have a more robust way of generating and test many models, right? So let's go. We're creating an IC, and it's the same as we had before. So I think this one will go empty, go blank. So as you can see, O and A now. Then call names. Now it doesn't have column names anymore. So we're going to give it column names, P, Q, AIC, BIC, right, what we wanted. Now it's the same for we did before. So we are doing an ARIMA model with no differences once again. And this is important here. Log differences. It's already talking about the changes it has comparing to itself. So it kind of serves the purpose of taking the differences. So we're not talking about actual values anymore. We're talking about change, right? So 0 for the I, and P and Q, we're going from 0 to 4. P from 0 to 4, Q from 0 to 4. Then, once again, we get we get the IC table that we have, matrix that we have, and we extract the AIC and BIC values. Let me run. Let's look at the IC matrix now. Look at that. All the guys are there, or our training 5 models. If you want to filter now for the log differences, 1, 2, 2, 1, 1, 1, 2, 2 for the AIC, BIC, 0, 0, 1, 1, 1, 0, 1, 2. That is, once again, we have a difference. And these models are not going to be too different from what we got for the differences before. So log returns, not too different from the differences we used. Delta Y differences. So running both of them, IC, AIC, IC, BIC. You see this, guys. AIC, this is the list. BIC, this is the order. One important thing, I should have said it before. Now, these are negative values. So when you sort them, this looks like larger than this one, but actually because it's negative, this is a smaller number than this one, okay? So AIC and BIC, we're always looking for the smallest score or information criterion. So we end up setting the same set of, the same adequate set as we had before. And let's check the residuals for these guys. As you can see, it takes a tiny bit of time. Let's go. For 101, it seems all right. The center seems to be at 0. Nothing relevant on the ACF. And the young box tag test, which is the most important thing, is really far from 0.05. Okay, so we do not reject the null hypothesis of white noise of the residuals. For B, 0.52, C, 0.51, and D, the fourth one, 0.13. Not rejecting for any of them, and as you can see, it's not really different. All the models are indicating kind of the same thing. Let's see if the 300, once again, we have very long on the lag number 10 and relatively long lag number 5, and the other ones not really. Okay, so we continue with our 4 sets because we did not reject the white noise hypothesis. Horizon, once again, will be 20 observations for January. X ticks, once again, the positions that we created before is just replacing actual R. We're getting it from the R guy that we had before. So if we click R, this is log returns, okay? So let's just extract the actual values for January 2022. Now, a list of forecasts for R, list of forecasts for R, it's an empty list to start with. And now it's a 4 doing all the things we did before. Let's print our forecasts. It's running from 1 to 4, length of our adequate set, right? And then we get the model. Let's see, the last model should be 300. 300. Then we generate a forecast using ARIMA, and we're using model PQ. The last one was 300, but it was a different one for each of them. Finally, we write the ARMA model. Once again, we came back to ARMA because we're not doing differences. So it's not an ARIMA model. We're just leaving a 0 for the D. So it's an ARMA model once again. Then we plot, and we ask to plot 2 horizons to the back. Everything again. Line. Now, call names. Look, log returns. It's taking the call names from R here. So these are the column names. And lines plotting what actually happened. And the axis plotting our lovely ticks to have a nice looking forecast. So let's go. Let's look at the quality. For ARMA 1.1, you can see it covers everything and a tiny bit there. And for the end one, it's outside of our 68% band, but it seems a tiny bit better than what we have for differences. And if you remember, it was coming off for this point here. It's not anymore. So it seems like a tiny bit better. Next one, ARMA 1.2. About the same, covering everything, just escaping the 68 band in the end. Next one, very similar. It barely changes. You can see this guy is not changing much. And finally, 3. It becomes a little bit more flat for 3 legs. Probably the third leg here is just creating kind of stability to the model. So instead of oscillating like the other ones, this little thing here, it becomes flat. And covers pretty well everything but the last observation, probably the last observation. It's a little bit off of the 68% band. And this is how well our log returns or log differences predict. Probably justifies why a lot of macroeconometric models prefer to have log differences or change in percentage instead of the differences in level or the data in level itself. And that is it for today. This was this last question and the comparison with everything, the forecasts. And this is what we did today. So at the end of this tutorial, you should be able to estimate a set of specified ARMA models using 4 loops. In this case, it was nested 4 loops, one inside of the other. Reduce the set of models using information criteria and residual analysis. So we looked at the lowest information criteria of the AIC and BIC, tried to do some combination. We got the top 10 and chose the ones that appear, the models that appear in both top 10s. Then we checked about the hypothesis of white noise of the residuals using the check residuals function from forecast and doing which does, among other things, an Young test, a Young box test. And finally, generated forecasts and predictive intervals for the specified ARMA models that were left in our adequate set. And finally, compared and evaluated forecasts obtained from different ARMA models. So thank you so much for attending this tutorial. Happy International Women's Day. And I'll see you next week.